Welcome to the deep dive, where we kind of do the sifting through the research so you don't have to.
Exactly.
And today we're taking a look at Google flu trends. You send over some really interesting stuff about it, and we're going to break down how it worked, this whole digital disease surveillance thing,
Right.
why it kind of fell apart, and most importantly, what we can learn from it.
Yeah, it's a fascinating case study. When Google Flu Trends launched back in 2008,
Mm-hmm.
it had this really, really kind of simple, elegant premise. Could we predict flu outbreaks just by looking at what people are searching for on Google?
Wow.
Right. The thought was that when people start getting sick, one of the first things they do is
Google it.
Yeah, Google their symptoms, try to figure out what's going on. So spikes in those flu-related searches could be like this early warning signal, even before people are going to the doctor.
So like a digital canary in the coal mine.
Exactly.
Mm.
And, at the beginning, it seemed like it was working amazingly well.
Yeah, I remember hearing about this. It was a big deal.
Oh, absolutely. I mean, they were claiming predictions 7 to 10 days ahead of the CDC.
Wow.
And at the start, they were reporting like 97% accuracy.
That's huge.
It was. It felt like, this could really revolutionize public health.
Yeah. So how did they actually pull it off? Like, what was the secret sauce?
So the core idea was really pretty straightforward. They were basically monitoring how often people were searching for, terms related to flu symptoms, things like fever, cough, sore throat, those classic signs.
Right.
Now, it's really important to point out that this was all based on the aggregated volume of searches. They weren't looking at individual users or their specific searches, so privacy was kind of baked into the whole approach from the beginning.
That makes sense.
Yeah. So what they did was they took Google search data going back to 2003, so a pretty good chunk of time, and compared it to the CDC's data on actual flu cases, the influenza-like illness or ILI reports. And using, some pretty basic statistical methods, what they did was they identified the top 45 search terms that seemed to historically increase when the flu was spreading.
So they found these kind of online breadcrumbs, like digital footprints that seem to follow the flu's path in the past.
That's a great way to put it. They were looking for those patterns in the data, and they used that to try to predict what would happen in the future. And, at first, like we said, it really seemed to work. It sort of validated this whole new approach.
But then 2009 rolled around and the H1N1 pandemic hit.
Right. And that was the first big real-world test for Google Flu Trends.
Mm.
And unfortunately, it didn't go quite as planned.
I see. So what happened?
Well, it turned out that Google Flu Trends significantly underestimated both the scale and the timing of the H1N1 pandemic. And, one of the key insights here is that models that are trained on, quote-unquote, normal flu seasons, they can really struggle when they're confronted with something completely new and unexpected.
Right.
The H1N1 pandemic was different. It fell outside the typical flu season, for one thing.
Uh-huh.
And there was this massive amount of media coverage, which probably led to people searching for information in ways they wouldn't normally.
Makes sense.
So, for example, they might have been searching for specific H1N1 symptoms or information about the pandemic itself, which wouldn't have been captured by those original 45 search terms.
Yeah. It's like the rules of the game suddenly changed and the model was still playing by the old rules.
Exactly. So this was a big wake-up call showing the limitations of this approach, especially when dealing with, unprecedented events.
So the system kind of underperformed during the pandemic, but the story doesn't end there, right? I mean, what happened next?
Right. So after that initial challenge with H1N1, things seemed to settle down a bit.
Okay.
But then, between 2011 and 2013, Google Flu Trends started to consistently overestimate flu activity. And this overestimation kept getting worse.
Oh, wow.
It culminated in the 2012-2013 flu season, where their predictions were more than double the actual flu cases reported by the CDC.
Whoa, double.
Yeah, more than double. And this wasn't just a one-time thing. I mean, this was happening week after week. For 100 out of 108 weeks, their predictions were way off.
That's a pretty big miss.
It was a huge problem. And there were probably several factors at play here.
Okay, like what?
Well, there was this growing sense of what some people call big data hubris.
Big data hubris.
Yeah, this idea that if you have enough data, if you have these massive data sets, then you don't really need to worry as much about careful analysis or understanding the nuances of the data.
Interesting.
And that could be a dangerous trap to fall into. Yeah. Another thing that might have contributed was that Google was constantly tweaking its search algorithms, to improve search results. And those changes, even if they were well-intentioned, could have unintentionally inflated the volume of certain flu-related searches.
Right, so the data source itself was kind of shifting under the model's feet.
Exactly. And then there's the role of the media. If there's a lot of news coverage about the flu, that can lead to more people searching for information, even if they're not actually sick. It's like that flu fear effect we talked about earlier.
Yeah, that makes sense. But it seems like the real underlying problem here, and correct me if I'm wrong, is that relying solely on correlations, even in these huge data sets, without really understanding the causal relationships, can lead to really unreliable predictions, especially when the data source itself is constantly changing.
You hit the nail on the head. That's the core issue. Just because two things happen to move to, they're correlated, it doesn't mean one causes the other.
Right. Correlation does not equal causation. We all learned that in stats class, right?
Exactly. And this whole debacle with Google flu trends
Hmm.
really drove that point home. And, it didn't go unnoticed by the academic community.
No, I bet not. I mean, this was a pretty high-profile failure.
It was. And there were some pretty scathing critiques published in academic journals highlighting these exact problems. The big data hubris, the lack of transparency in the model, and the fundamental flaws of relying solely on correlations.
And the fact that Google's search engine was constantly changing, that didn't help either, right?
No, it didn't. It made the whole system even more unstable and difficult to predict. So, with all these issues mounting, what was the ultimate fate of Google flu trends?
Yeah, what happened in the end?
Well, in August of 2015, Google finally pulled the plug. They stopped publishing real-time estimates of flu activity.
I see.
The ongoing inaccuracies had just made it, essentially unusable as a reliable source of information.
So it was kind of a noble effort that ultimately didn't pan out.
Yeah, I think that's a fair assessment. But, it wasn't a total failure. I mean, Google Flu Trends was really a pioneering effort in this field of digital epidemiology.
Right.
It showed the world that there was this huge potential in using online data for public health surveillance.
Hmm.
But it also highlighted the significant challenges and pitfalls that come with it.
Yeah, a valuable lesson learned, albeit a bit of a hard one.
Absolutely. And it paved the way for more sophisticated and nuanced approaches that we're seeing today.
So before we get into those more modern methods, can we rewind a bit and talk about the technical details of the original Google Flu Trends algorithm?
Sure. So, as we mentioned earlier, they started with these 45 search terms that were selected based on their historical correlation with flu cases reported by the CDC.
Right, the digital breadcrumbs.
Exactly. And they use a pretty straightforward statistical method, a linear model, to basically see how much the frequency of those searches lined up with the actual flu cases from the past. They looked at data from 2003 to 2007, and they chose the terms whose volume during that period showed the strongest statistical link to past flu seasons.
Okay, and were those terms ever made public?
That's actually an interesting point. Those specific 45 terms were never publicly disclosed by Google.
Hmm, that's kind of intriguing.
It is, and there was actually some criticism around that lack of transparency.
Makes sense. So they had their data, they had their model, they had their secret search terms. What were some of the key areas where things went wrong in terms of validating those predictions and making sure they were actually accurate?
Yeah, that's a great question. So several key issues were identified in later analyses. One of the big ones was population representativeness.
Meaning?
Well, you have to ask yourself, are the people searching on Google truly representative of the entire population in terms of their health and their likelihood of getting the flu?
Right, not everyone uses Google, and even among those who do, their search behavior might not perfectly reflect the overall patterns of illness in the population.
Exactly. And then there's that flu fear effect we talked about earlier.
Yeah.
If there's a lot of media coverage about the flu, that can lead to more people searching for information, even if they're not actually sick, which can skew the data.
Yeah, it's like those panic buying runs on toilet paper we saw during the early days of the pandemic.
Exactly. It's a similar phenomenon. And then there's the issue of independence between the data sets. Ideally, you want your data points to be independent of each other. But in the case of Google Flu Trends, there were clear dependencies.
Oh, I see. Like how past flu data can influence present flu patterns.
Exactly. Flu seasons are often influenced by what happened in previous seasons.
Right.
And then, of course, there's the impact of Google's own algorithm changes, which were completely external to the flu itself, but could still have a big impact on the search data.
It's like trying to hit a moving target while standing on a platform that's also moving.
That's a great analogy. And then there's the issue of data size and statistical significance.
Okay, explain that one.
Well, the initial training data for Google flu trends only went back to 2003, which isn't a huge amount of data when you're dealing with something as complex and variable as flu seasons.
Hmm.
And that limited amount of data made it really difficult to predict rare events like the H1N1 pandemic, which fell outside the patterns the model had learned.
Yeah, it's like trying to learn a language by studying only a few pages of a book. You're going to miss a lot of the vocabulary and grammar.
Exactly. And finally, there's the issue of structure preservation. The standard ways of checking a model's accuracy, things like cross-validation, they don't really work well with time series data, where the order of events matters.
Right, because flu seasons have this clear temporal structure. They evolve over time.
Exactly. And those standard methods didn't really account for that. Plus, there are geographic variations in flu patterns that the model didn't fully capture, and its ability to adapt to changes in seasonal patterns was limited.
So basically, the model was built on shaky ground and was using tools that weren't quite right for the job.
Yeah, I think that's a fair summary. So, with all these limitations in mind, what have we learned from the Google flu trends story? And how are modern approaches to digital epidemiology trying to do things better?
Right, because this whole field hasn't just been abandoned, has it?
No, absolutely not. I mean, Google Flu Friends was a bit of a cautionary tale, but it also opened up this whole new world of possibilities, and researchers have taken those lessons to heart.
So what's changed?
Well, one of the biggest takeaways is the critical importance of understanding how your data is generated and what potential biases might exist within it. You can't just blindly trust big data.
Right, you have to be really critical and skeptical of where the data is coming from and what it might be telling you or not telling you.
Exactly. And transparency is crucial. Researchers need to be clear about their methods, their data sources, their assumptions, so that others can scrutinize their work and replicate their findings.
Okay, so more transparency, more critical thinking about the data. What else?
We've also developed much more sophisticated ways to validate predictions over time, using techniques that are specifically designed for time series data. And we've learned that continuous monitoring and retraining of models is essential. The world is constantly changing, flu viruses are constantly evolving, so your models need to be able to keep up.
Right, it's like a constant arms race between the model and the real world.
In a way, yes. And perhaps most importantly, we've learned that you need to combine these digital data sources with traditional knowledge from experts in the field, like epidemiologists, who have a deep understanding of how diseases spread and how to interpret the data in a meaningful way. You can't just rely on algorithms alone.
So it's about bringing together the best of both worlds, the power of big data with the wisdom of human expertise.
Exactly. And that's led to the development of much more sophisticated models. For example, there's a successor to Google Flu Trends called ARGU, which stands for Autoregression with Google Search Data.
Okay, tell me more about ARGU.
So ARGO is actually a pretty clever approach. It uses Google search data, but it combines it with CDC reports, so it's drawing on both digital and traditional data sources.
Okay.
And it dynamically selects search terms, so it's not limited to that fixed set of 45 terms that Google Flu Trends used.
Interesting.
It also takes into account seasonality and other factors that can influence flu patterns. And it uses a moving training window, so it's constantly updating itself with the latest data. And you know what? It's actually performed much better than the original Google Flu Trends.
Wow, so it's like Google Flu Trends learned from its mistakes and evolved into something better.
Yeah, I think that's a good way to look at it. And ARGO, just one example. I mean, current methods are using even more diverse data sources. Things like social media posts, electronic health records, even weather data.
Wow.
And they're using more advanced machine learning techniques like neural networks and ensemble methods. But the key is that they're all being developed with a much greater awareness of the need for rigorous validation and a healthy dose of skepticism.
So it sounds like the field of digital epidemiology has really matured since the days of Google Flu Trends.
It has. And it's an incredibly exciting field with enormous potential to improve public health surveillance and response.
So to wrap things up, what are the big takeaways from our deep dive into Google Flu Trends?
Well, I think the biggest lesson is that even with vast amounts of data, careful methodology, critical thinking, and collaboration between data scientists and domain experts are absolutely essential for accurate forecasting and decision-making.
Right. It's not just about the data, it's about what you do with it and how you interpret it.
Exactly. And for you, the listener, I think the key takeaway is to always approach seemingly powerful data-driven predictions with a healthy dose of skepticism.
Right, don't just take things at face value.
Understand how the data was collected, look for potential biases, and remember that correlation doesn't automatically mean causation.
Excellent advice. And, this deep dive has really just scratched the surface. I mean, there's so much more to explore in the world of digital epidemiology.
Absolutely. I encourage you to check out AGO and some of the other modern methods that are being used. It's fascinating stuff.
And it makes you wonder what other unexpected data sources might be out there that could give us valuable insights into how our society functions and how we can improve people's lives.
That's the big question.
Yeah.
And I think the answer is we're only just beginning to discover the possibilities.
Well, that's a great place to leave it. Thanks for joining us on this deep dive into Google Flu Trends. Until next time, keep questioning, keep exploring, and keep diving deep.
Thanks for having me.
It was a pleasure.